In this video, we're going to consider how you work out trigonometric exact values for multiples of the common angles. So the common angles, like 30, 45, and 60 degrees, or their radian equivalent, they're the ones that you should know kind of off the top of your head. But what happens if you have to work out something like the sine of 225, which is a multiple of 45, or the cosine of 2 pi by 3? So there are multiple methods for this. I'm going to use the cast diagram. Hopefully you're familiar with the cast diagram. So what we do, we start by just marking up a cast diagram, just like you would normally use the cast diagram in trigonometry. Remember, it starts here from 0 going counterclockwise. So this is the C quadrant, A, S, and T. Just take the angle you're interested in, 225 in this case, and mark it on the cast diagram. Remember, you're rotating this way, so 90 degrees, 180, 225 would be somewhere like here. So that rotation there is 225 degrees. But the important thing is, whichever quadrant we've ended up in, this time the T quadrant, there's going to be a new angle in there, which in this case is 45 degrees. So it's 180 degrees to there, but 225 to there. So that leaves an angle in there by simple geometry of 45. As soon as you get that new sort of reference angle, it means that this original calculation, the sine of 225, can then just simply be made into the sine of 45. So you're just transferring the problem from something you don't know to something you do know. And this new angle will always be either 30, 45, or 60 degrees, or the radian equivalent, because those are the angles that you're meant to know the exact values for. So one thing to note with this, it's always the angle here rather than the angle here you make. So it's the angle touching the horizontal axis, okay? But the reason we put it on a cast diagram, notice we've ended up in the T quadrant, and in the T quadrant, the sine function is negative. So not only is it the sine of 45, it's a negative of the sine of 45. Sine of 45 is 1 over root 2, or root 2 over 2 in its rationalized form. So that's just going to be minus 1 over root 2, or minus root 2 over 2. So that last part, the sine of 45, 1 over root 2, you should just know that. That's one of the exact values. Okay, so we're just transferring the problem from one angle onto another, to an angle that we know. The same method works in radians. So a lot of students like to convert radians to degrees. To be honest, I like to convert radians to degrees. They're just easier to generally work with. So pi over 3, 180 divided by 3 is 60 degrees, times 2 is 120. So this statement here is just the equivalent of the cosine of 120 degrees. That's not a value we know off the top of our heads. It's not an exact value. So we're going to go through the same method here. So again, just fire up a little cast diagram. Doesn't have to be too pretty, doesn't have to be artistic, just a quick representation. So again, starting here from 0, marking on 120, so 90 degrees to there, 120 would be to like here somewhere. Yeah, somewhere like here. So that there is a rotation of 120 degrees. That then, by simple geometry, is going to leave, that's 180, so that's going to leave a gap here of 60 degrees. So that 60 degrees becomes our new reference angle. So that tells us that this is equal to the cosine of 60 degrees, which is one that we know. So again, though, be aware of what quadrant we're in. We're in the S quadrant, the sine quadrant, where cosine is negative. So again, we need to put a little negative in there. If we had rotated all the way through to the C quadrant, where cosine is positive, we wouldn't need a negative. So it's only if you land up in a quadrant where the function is negative that you need a negative. Similarly, if we were in the A quadrant, then we wouldn't need a negative either. So the cosine of 60 degrees from exact values is 1/2. So this becomes minus 1/2 as a final answer. So that's how you work out trigonometric exact values for multiples of the common angles.